He has been into industrial engineering for over 18 years. The advantage of having Engineer Goriwondo is that he is worked in industry, having worked at BP and Shell. You know, he's also worked at Eternal Fiber Cement before crossing over to the academic. Now, he is now linking the university with industry. So we'd like to request Engineer Goriwondo to come and share with us that experience. If you could please clap hands for our engineer.
The Director of Ceremonies, Mr. J.T. Dewa, the Deputy Minister for Higher and Tertiary Education, Science and Technology Development, Honorable Dr. G. Gandawa, Lupane State University Vice Chancellor, Professor P.K. Kuiba, the ZimDev CEO, Mr. F. Mandijida, National University of Science and Technology Director of Communication and Marketing, Mr. F.F. Moyo, Lupane State University Dean of Commerce, Mr. C. Impala, ZimDev Principal Director for Finance and Administration, Mr. N. Mapute, the Principal Directors from Ministry of Higher and Tertiary Education, Science and Technology Development, Directors from the Ministry of Higher and Tertiary Education, Science and Technology Development, Captains of Industry here present, ZimDev Management, ladies and gentlemen. I'm honored to stand before you and present our view and support for STEM from the university side. It is my singular honor that I go through this presentation. I understand captains of industry are here and the linkages that are being advocated for are presented here. I take the challenges that have been presented by the Honorable Deputy Minister, also the ZimDev CEO. The challenges are facing all of us and we have to work together. In this presentation, I'm going to take you through an introduction, then I'll go on the deliberate policy on to industrialize, then industrialization and modernization, looking at what is it and what are the drivers of that. Then the roles that the universities play, and then the project that we at NAST have done in support of STEM. Then also we face challenges and limitations, going to present them with the hope that this forum will be able to help us resolve those. What industry say to us? We have engaged industry. They talk to us as universities, their expectations, and I will present that. Then we'll go to the recommendations and the conclusion. The higher learning, teaching, learning, and research institutions have a role to play in STEM. And this role here needs to be recognized and also supported by all players. And there are lessons that we can learn from those that have gone through this path. We cannot go and reinvent the wheel. I think the ZimDev CEO, Mr. Mandijida, presented on the things that are there, which have been done, and we need to take from those and move them forward. Then this STEM initiative is quite critical for our nation in regards to modernization and industrialization. I like the presentation on Industry 4.0 and what needs to be done. So we need to actually capacitate and transform universities to support this STEM initiative. Here I've got a slide which is showing the Zimbabwe imports versus exports from 2009 to 2015. And what's in black there is showing what we have imported against what we have exported. And we are saying this is not a good picture for our nation. What we need to do, we need to export more and import less. That way, we'll be actually creating wealth for the nation. So the question is, can supporting the STEM initiative have on this and reverse so that we actually have more of our exports than the imports? As a nation, we have this Zim asset, which is a deliberate policy to industrialize. I can quote from the preface of the Zim asset document where they are saying it advocates for accelerated economic growth and wealth creation. And how do we do that? We know that Zimbabwe is endowed with a lot of natural resources, mineral resources. I think we are aware of the Great Dike, the minerals that are there, our land, the farm produce, all those are resources that we can capitalize on. So we need to largely and judiciously exploit those resources, and then we would actually create wealth for the nation. The clusters that are there for the Zim assets, we have got food security and nutrition, we have social services and poverty eradication, infrastructure and utilities, value addition, beneficiation, fiscal reform measures, public administration, government, and performance measurement. These clusters here are there to support the wealth creation that we aspire for. If you look at value addition and beneficiation, we are saying the natural resources that we have, how best can we capitalize, extract them, value add before we send them out. I think we are all aware that value-added products cost more than the raw materials that make the product. Looking at those that have gone through this path before, I took just one example. Japan, it's not the only one. There are a lot of them that have gone through industrialization. They said theirs was investment-led growth, where there was investment in. They say we have raw materials. If we don't have the infrastructure to transform those raw materials, we will not achieve what we require. So it's important that we realize that when we invest in the industry, in the infrastructure, then the assets can be actually achieved. But there are those that I put a question mark there. The investment in manufacturing capacity was largely left to the private sector. I am saying here what we need is to collaborate, all of us, government, industry, institutions of higher learning, so that we actually move forward in this regard. Then I looked at, we are advocating for industrialization and modernization. What is, sorry, I think it's now jumping. The one on. Right. What is modernization? On the pictures there, smart things, Internet of Things. I think we are all aware that we have got these smartphones which can do a lot for us. One presenter previously talked about a smart home which can actually wake you up, which can tell you things are not okay outside, and then you can interact even if you are here. It will tell you there is an intruder. Those smart homes, this is where we are saying we are actually utilizing technology to modernize. Here I picked on some characteristics of modernization, application of technology and mechanization. If we can actually mechanize there, we are digging trenches, and here we are digging trenches. And there we are mechanized, here we are using the hoe, which is the traditional. Is it that we want to do? If we can mechanize, our modernization will be fast. Then there is industrialization, urbanization, then rise in national per capita income. And if we are saying rise per capita national income, we are saying each one of us is producing more than we previously have been doing, and it is desirable. then political participation, increase in literacy, then development of mass media, technologies, social mobilities, cultivation, and national identity. The Honorable Deputy Minister earlier on talked about robots. These are robots, and those other ones are traffic lights. But we in Zimbabwe refer to the traffic lights as robots. We can have robots which can do firefighting, which can be on a manufacturing line, and if you are on a rescue mission, these robots can actually go in there where humans cannot do, and this is what we call modernization. On the other hand, what is industrialization? In industrialization, we are looking at sustained economic development based on value addition and concentrating on industries. Our industry base in Zimbabwe, I think due to economic challenges, have gone down. And we are saying we have institutions of higher learning, we have industry who are in the business of doing business, and we need to revive those industries so that we value add and we beneficiate. Then some characteristics of industrialization, mechanized mass production, we need the volumes that come with this, then economic growth, then efficient division of labor. I think the previous speaker talked about the efficiency that is required. You want to get more from the little that there is. That is what we call efficiency. Then technological innovation. If it cannot be done technologically, why don't we adopt that? It's important for our nation. The drivers of industrialization and modernization. We need an enabling policy framework. This is where the government comes in to put the environment right so that institutions of higher learning can actually deliver. I think it talked about the engineers coexisting with the potholes. I, as an engineer, I take it as a challenge, but we also need an enabling policy framework to facilitate us to sort out the potholes. Then there is need for innovative research and technology solutions. If we can have the technology that can sort out the potholes, it will be better for us. So we need that. Then stakeholder engagement and involvement, the blame game should be stopped, where we come together and resolve that. Then research, uptake, and commercialization. The projects that we engage in at institutions of higher learning, they need to be commercialized. They need to be taken up. Someone out there should be saying, this project, this is a good idea, I can take it up or put some little bit more money, make it viable, then we have it as a commercial product. And what are these commercial products? I think our day in, day out will be having products that we are using, be it laptops, computers. They were developed somewhere, but someone took a deliberate decision to commercialize those. Then we have globalization as a phenomenon, where people in India, in China, in Tanzania can compete with us here. And we need to stand up to that challenge. Talking about research, innovation, and technology solutions, my question is, who can do research? A researcher can do research. Who can innovate? Anyone can innovate. Now it is together, industry, institutions of higher learning, you innovate. If there is an idea that is researchable, ask the researchers, they have the time to do the research. Then the motivation to do research, it could be the problems that we are facing, the challenges. We could be having no choice but to do the research, or it may be out of interest. But the major one, which I think the Honorable Deputy Minister and the ZimDev CEO say, let's have solutions to the problems that we are facing, and we encourage our students to research on that. And then what then happens to the research output? It needs to be commercialized, and there are intellectual property issues. Coming to the roles of universities in this, here I've put a vision for NAST to be an international center of excellence in science and technology and entrepreneurship for sustainable development by 2015. and the mission there is talking about spearheading human capital development. With people, we need to see that we attain modernization, industrialization, and NAST is there to take up that challenge there. Sorry, the technology is moving very fast. Right, I've talked about research. We also did teaching and mentoring of students, and here the emphasis on relevant and modern material. If our students come to universities, we need to be teaching them things which will enable them to take up jobs for the future, not redundant material. Therefore, this calls for research at higher education institutions. Then the National University of Science Technology, here are the faculties: Applied Sciences, the Built Environment, Faculty of Commerce, Communication and Information Sciences, Industrial Technology. Then we have the Institution of Development Studies. The departments which are in the Industrial Technology, there is Chemical Engineering, Civil and Water Engineering, Electronic Engineering, Industrial and Manufacturing Engineering, then Fiber and Polymer Materials Engineering. These are the departments that conduct research in the field of technology upgrades, but they will be supported by the all other faculties in the university. The Faculty of Industrial Technology, those programs there, they are 5-year programs, and this 5-year include 1-year industrial training attachment. Then the role of the industrial training attachment is to expose the students to the real world. And there they can actually identify some problems that industry are facing and then develop projects that they come back either for their final year to take up and research. We've got engineers out in industry who we request to mentor our students. So we'll be relying on bridging this discrepancy and also benchmarking on what's in industry and what at academic institutions. Our main challenge will be, you find when they go out there, they encounter equipment which is more advanced one than what they are using for learning at the university. So we need collaboration there whereby you can allow our students from NAST or universities to come and do certain research with your advanced equipment. Then we'll also be facilitating real life problem solving for them. Here we have got some projects which we conduct at NAST. This is in conjunction with the Zimbabwe Institution of Engineers. There is the National Engineering Students Awards Competition, which is now an annual competition where students compete on their final year projects. And this was at Chinoy University of Technology, the team from NAST that had gone to that. And the institutions which are in that as UZ, HIT, Chinoy University of Technology, as well as NAST. Some of the projects that have been carried out, these ones are the ones that are going to be competing this year. Head motion controlled wheelchair, using of lead-based biopolymer in improving gold recovery during cyanide leaching of sulfide oils, structural design for an interchange overpass bridge, colorant extraction from beetroot. Some of the projects that are being conducted by the students, and if you relate, these could actually be trying to solve problems that are in industry. I just want to, the previous slide here. This is the 2016 competition which was held. Internet of Things based intelligent greenhouse was developed by a student, and these are some of the projects also which are showing that we are actually doing research that is related to solving the problems that we encounter, and we are also looking into the future. Then we also having supporting STEM at high schools. We have got We have got some bridge building competitions, water competitions, robotics that we carry out with the high schools. Our staff members, our engineers would actually go out into the high schools and facilitate these competitions. The robotics competition, where they are building some robots, give them instruction. We use microcontrollers, Arduinos, Raspberry Pis to give instructions, and then the one that comes closest to what we require is what would actually win. Some pictures there from those bridge building competitions which have been held previously. Then the challenges that we face. Industrial training attachment, we are appealing for placing our students. Then mentorship, the experienced captains of industry need to mentor our students, and also some grants which will facilitate the students to go to and from work. Then on funding, we also need laboratory space so that we can actually carry out experiments, do research to conclusions. Then equipment and consumables, access to literature. We also need to benchmark with what is happening in the world. Then we have a challenge whereby interest for research is not key to industry. That's an observation that we have made. Industry may be sticking to traditional ways of doing things. I think the challenge is now upon us due to the Industry 4.0 to take up this. So there could be fear of the unknown, too busy to allow research. Some may actually point out confidentiality issues and not allow researchers to come in. Then difficulty in maintaining momentum. You start research, it doesn't get to the end. Then research facilitation and uptake. Once it's done, we need someone to take up the solutions. Some of them may actually solve the real problems that industry will be having. Then commercialization, that would result in benefit to the whole nation at large. Then on the NAS project, sponsorship is limited. If organizations are out there who can assist, some of our students want hardware to carry out research, and we need money for that. Then the workshops and laboratories, we may request access to your laboratories so that we conduct research. Then the limited support in areas of renewable energy, I think I picked some examples. Then limited communication and financial support on national projects. As these are presented, we need to take them up and resolve the problems. Then for high school STEM initiative competitions, we won't be looking for a lot of money. Sponsorship for holding these competitions could be a shield, $100, $500. Equipment to use for robotics, we need controllers. These may cost $50, $100, depending on the number of schools that are in there. Then transport for mentorship to schools. Our engineers, our staff going out there to mentor these kids in support of STEM. Then also, if they win, they may need to travel to South Africa, to Harare, and we require transport and accommodation for that purpose. We also talk to industry as an institution at a Royal Academy of Engineering workshop, which was entitled Enriching Engineering Education Program. And the industry, we had asked them, what is it that you expect from the graduates from these institutions? They said that no. We asked them their perceptions of our graduates. They said they do not meet expectations. Skill supply cannot keep up with demand of technology changes. Significant skills gap arising from the disconnect between education and curricula and industry needs. Then inadequate input of industry into education. They are calling for collaboration. Then misaligned between policy and curriculum, and those that need to be addressed. We also asked them what they expect of our graduates. Sorry about that. I think it's slow. When I press twice, it goes very fast. Okay, all the same. What they were saying is what we need, we expect from you is the graduates that will take up jobs of the future. And their recommendation was basically zoning in on saying we need collaboration between industry and academia. And with that, I developed a model which whereby we are recommending this partnership where we have academia, industry, and ZimDef there. And in the triangle, we need each other to actually move forward. And in conclusion, it is desirable to modernize and industrialize, and all stakeholders need to be engaged. In universities are trying their best, but they need support. We need to capacitate these tertiary institutions so that they can actually take up and support the STEM initiative. We have a number of graduates, 2,000 every year. They do projects, and these end up in institutional repositories. There may be need for developing further and uptake of these projects. I thank you.